Hello everybody, welcome to Pencil College. Now in this video, we will learn about chapter 19.4 of the textbook, which is the integration of exponential and inverse functions. Okay, so we have learned how to differentiate them, uh, exponentials and logarithmic functions. So now we will learn how to integrate exponential, because differentiation of exponential functions is still exponential, and differentiation of logarithmic functions are just inverse functions. Okay, so now we learn how to integrate them. We would expect to get back those two exponential and logarithmic functions. Okay, so after we differentiate our exponential and logarithmic functions, we will get these two forms. So learning how to integrate them would be simple. It will just translate back to the previous form. Okay, so as we have known already, the general formula will look something like this. So if I differentiated e to the power of ax plus b, I would actually get a e to the power of ax plus b. So if I integrate this, I would actually get 1 over a e to the power of ax plus b plus c. Okay, so these are all constants once again, and this a came from this a. Okay, and this a came from this a. Okay, so it's just doing the reverse. So if you actually differentiate this term over here, you get back this term. Differentiate this thing here, you get back this thing. You can try it. So this is pretty simple. Let's start with one example. Let's integrate the function y is equals to 5 bracket minus 4x plus 2 close bracket to the power negative 1. So if I can actually rewrite this thing, I would actually want to rewrite it into a form that we are more familiar with. So 4x minus 2. Okay, so what I have actually done here is I I I, I took out a minus sign from the denominator and put it to the numerator. Okay, so this one I can actually write it as 5 or negative 5 over 2 1 over 2x minus 1, okay, which is negative 5 over 2 2x minus 1 to the power of minus 1. Now if I integrate this, 2x minus 1 to the power negative 1 with respect to x, what I would get is just, okay, I can bring out the negative 5 over 2 first, as we have learned in the second video of integration. You can go and review it. Okay, and we can bring this thing out, and then what we will get is just negative 5 over 2. Integrating this will give me half times ln of 2x minus 1. Okay, and this is just negative 5 over 4 ln 2x minus 1 plus c. Oops, okay, actually I forgot to put a plus c here. I must plus c. Okay, so the limits of integration must be included as well. Okay, but another way of doing this question would be writing it in this form. So say similarly I write it as a 4x minus 2. Okay, then I take it as negative 5, and then 4x minus 2 to the power of minus 1 dx. Okay, and then this is actually equals to negative 5 1 over 4 ln 4x minus 2 plus c. Okay, and this is just negative 5 over 4 ln 4x minus 2 plus c. Okay, take note that this answer here and this answer here is not the same. However, both are correct. Okay, so whatever is here, I can actually convert this form into this. I can convert from this form to this form if if this c is arbitrary. Okay. However, when I do a definite integration, if I change this to a definite integral from two different limits, from two I put two limits here and two limits here which are corresponding to each other, then I would actually get a same answer. Okay, so the indefinite integral is not unique. Okay, that's what we mean by the indefinite integral is not unique, but the definite integral is definitely unique. Okay, so I can actually convert this form to this form or this form to this form. Okay, I can actually convert it. Okay, maybe I can demonstrate how I convert this form. So from this form, I can actually change it to be equals to negative 5 over 4. And then this is just ln 2 times 4, 2 times 2x minus 1 plus c. However, okay, this one also has to be times by the negative 5 over 4. Okay, however, you know that when we have ln 2 times something, this is just actually ln 2 plus ln 2x minus 1, right? Okay, and then plus c. Okay, so if you look at this part can be absorbed into the c. So it will just become negative 5 over 4 ln 2x minus 1 plus c prime. Okay, where c prime is just c plus negative 5 over 4 ln 2. Okay, so you can actually see that they are interchangeable, these two forms, just that these two c's are different. Okay, these two c's are actually different. Let's try another example. So y is equals to 4e to the power of negative 2t. We want to integrate it from 0 to 0.5 ln 2. Okay, so integral of 4e to the power of negative 2t, we want to do it from 0 to 0.5 ln 2. Well, let's put it into a form that we are more comfortable with integrating. So 0.5 ln 2 e to the power of negative 2t. Well, this is 4. And then integrating e to the power of negative 2t will just give me negative half e to the power of 2t. Okay, you can differentiate this thing, you should easily get back what is inside the integrand. Oops, forgot the dt. You should easily get back the integrand. Okay, and then from 0 to 0.5 ln 2. Oops, wrong notation over here. There should not be any more integration sign here. Okay, it should just be a square bracket. 0.5 ln 2. Okay, and then for negative half e to the power of negative 2 and 0.5 ln 2 minus half e to the power of negative 2 times 0. Okay, oh, and the 4 also have to multiply by all of them. So all I'm left with 4, and then negative half e to the power. Okay, here we have to do some simplification. So I'm left with negative half e to the power of 2 times 0.5 is 1. So e to the power of negative ln 2. So negative e to the power of negative ln 2 is just e to the power of ln 2 to the minus 1. Am I right? and this e to the power of ln 2 minus 1, this is just 2 to the power of minus 1. Okay, and then I have to minus off this part over here. E to the power of this is 0, this is 0 on top, so e to the power of 0 is always 1 minus half. Okay, and this is just half and negative half over here, so it's just 4 times half times negative half is negative quarter, minus half is half, and then I'll be left with a quarter, right? And then 4 times a quarter is just 1. Okay, so with that I've solved this question. So in summary, we have learned how to integrate exponential functions as well as inverse functions. This one, after integrating, gives back an exponential, and this one gives a logarithmic function. Okay, so after integration, right? So in summary, we have learned this, and so now you can try out some of the problems from your textbook. The PenPax textbook have a few examples on this, so you can go and try them out. So with that, I thank you for watching this video. I hope you enjoyed the video. For more video, please visit pencilcollege.com. Thank you.